Well, thank you for staying at this late hour after a day filled with lots of stories, which I think also were a lot about change. Change is everywhere, and managing change and using change to be actually successful is really important. And that's also where we come up with this title. Actually, when we look on bol.com, there's a book by a famous Greek philosopher, Heraclitus in Dutch. And you can actually buy this book if you want.
3 guesses as to where we want you to buy it.
And this is what he actually said. I'm not going to read it because I'm not that fluent in Greek, but I'm going to translate it. And what he said was that everything changes and nothing stands still. I think that really describes bol.com as I have experienced it, but I think that it describes the whole world and also the organizations you are in. A little bit about myself. A long time ago, I started out as a biologist, and then via diverse roles in different companies, I ended up at bol.com. First started out in a team working on personalization of the website, and then at a certain moment, I or other people decided that it would be better if I not would write code anymore. So I came into management, and currently I'm community director at bol.com. But the biologist is still there. And Charles Darwin is, of course, one of the biggest biologists who ever lived. And in his revolutionary book, The Origin of Species, he described how evolution worked. And one of his more famous quotes is that it's not about the strongest of species that survive, nor the most intelligent that survives, it's the one that's most adaptable to change. Listening to Rini, I think that we could change it a little bit, that it's the one that learns the fastest which might survive. A very interesting point about this quote is that Charles Darwin never said it. It was somewhere paraphrased in the 1970s, but he actually never said this. What he did say at a certain point, and which I really think is a very good quote, is that the change is difficult and not to change is fatal. Or, as Rini might put it again, to learn is difficult and not to learn will be fatal. Last week I went to a talk, and there I saw that Darwin and evolution and things are still very actual happening in the world today. With the gradual urbanization of our world, species, animals have to adapt to the world. And sometimes that goes well, and sometimes it doesn't go well. This is the famous McFlurry hedgehog. It's actually in the museum now, and what we have seen is that hedgehog, they have developed a craving for McFlurries. There's one little problem. They can enter it, but because of their needles in the back of the head, they cannot go back anymore. And then they run into traffic, and they die. So maybe they should change. Maybe they should evolve, not to like McFlurries anymore. Actually, McDonald's changed their McFlurry packages to have a smaller hole, but not adapting would not be great. I'm actually not going to show you this video. I think maybe you can go home and learn, will this end well for this little hedgehog, or will he be run over by traffic? So today we're actually going to talk about several things. I'm going to give you a brief history of bol.com, because if you don't know the history, then you cannot place the story we tell in a context. And then I'm going to talk about 5 revolutions/evolutions which happened at bol.com, which made us the company we are now. Sometimes you need a revolution, sometimes you need an evolution. And then Maarten will take over from me and will tell you about our latest change, our migration to the Google Cloud Platform, or maybe our move to the Google Cloud Platform. So this again comes with a warning, and I think Sander, don't know whether he's still here, but this is the same thing. Everything works somewhere, nothing works everywhere. Don't start copying what other people are doing. Get inspired, but don't copy it as a whole. Simple metaphor again with evolution. Polar bear would work perfectly in the North Pole, but it definitely would not work in the desert. So 20 years of history. We actually started out in a Porto cabin, in the backyard of the ECI Book Club, which was owned by a German company called Bertelsmann. There we started out with 4 people, and we became part of Bertelsmann's ambition to be the first worldwide online entertainment store in the world. Therefore the name bertelsmannonline.com, bol.com. And in 1999, bol.com was launched. Bol.com in the Netherlands was launched. But 3 years later, with the dot-com bubble bursting, Bertelsmann decided let's not go on. But actually, bol.com was really doing well in the Netherlands. So our CEO at that time convinced Bertelsmann to sell it to 3 German investors, and the rest is history, I think. In 2012, bol.com was then acquired by Ahold, and this gave us the opportunity to grow even faster. When you look at bol.com, we also started evolving actually from a media store to a shopping platform. We started adding new categories. We started out with books, then added entertainment. Now you can buy appliances, you can buy sports and outdoor, you can buy kids' clothing. We also started to open up new business channels. We started out by letting people sell second-hand books. We started out with old pickup points. We started out with digital reading. We changed, and we changed a lot. We also expanded to the Dutch-spoken part of Belgium. But actually, currently, we're also, again, in a great transition. We're moving from a shopping platform, where bol.com is the predominant player, to a platform where we allow partners to sell their products. Other companies than bol.com sell their products via bol.com. So actually, from a store to a network of stores selling products to our customers. Currently, we have 9.6 million active customers. Anybody buy something last few weeks? Wow, goodish, good enough. Okay, we have about 60 million average monthly visitors. On Black Friday, very early in the morning, we already did 3,300 requests per second on our website, and we have a catalog which contains about 18 million different products. And when you look at our partners selling products via bol.com, there are already 23,000 different partners selling stuff via bol.com. And still, 180 people trying to get rid of their second-hand books also have a go. Actually, at bol.com, we think that the customer and the partners are the center of the universe, like Rini also said. We have the belief that bol.com doesn't have customers, the customers have bol.com. At least, that's what we're saying. And to do that, to keep that customer happy, we need to innovate at a rapid pace, and we also need to be available 24/7. That's a challenge we have, and also, because we're in retail, we kind of have to think about the financial scalability of things. Margins in retail are not that great, I think, and you really need to think about the solutions you build today should scale tomorrow and maybe even after. It should not be about adding more people to make your processes scale. So actually we grew from 1998 from 10 people to 1,500 people working at bol.com in 2019. When you look at the guiding principles in our ways of working, we're quite inspired, at least I'm really inspired by the book written by Daniel H. Pink called Drive. And it shows you why people get out of bed in the morning and drive to work to really engaged in the things they do. People want to have autonomy. They want to feel in control. They want to have mastery. They want to feel like they're using their full potential, all the skills that they can do, and grow. And the last thing, and it really is very important, they need to have a purpose, to feel that their work matters and that they make impact. That's really important. And it will come back in the rest of the story. So, when looking back in time, I'm looking at the last 10 years, I think. In 2009, we started with Scrum. And actually, the evolution of working together, of the innovation is actually the evolution of innovation is in ways of working together. When we were still in the Porto cabin, things were easy. The most difficult thing was who's going out to get lunch in the afternoon. There was no formal process. People were just working together. And this was a small team who set a very common goal and had a basic division of tasks. And everybody had was a single point of failure, which also gave them a real sense of purpose. But then we started growing. Our success became better, and at a certain point, well, you think we need to manage this. We need to add control. We need, some kind of way to control this part. And then we started formalizing innovation. Actually, we started introducing waterfall methods. And what actually happened, that our time to market really increased. You could only work on one thing at a time, and it really didn't. It attracted more and more resources. Like Sander said, project really sucked the life out of everybody. And especially at that point, we were introducing a new webshop engine, and that project got delayed and got delayed and got delayed and got delayed. And at a certain point, it was not sustainable anymore. We had to do something. And then agility went down the drain. So we decided we needed a revolution at that point. And then, in a course of only 3 months, we decided what we want. So we wanted a shorter time to market, we wanted parallel development in all strategic directions, and we wanted to have more fun and engagement. So maybe Scrum. We asked the consultants of Xebiak, Scrum, maybe a good idea. Yes, let's do Scrum. We formed teams together, the POs together. We trained the business and IT. We had the team staffed, and 19th of January we had Sprint 1. In a course of 3 months. That's a revolution, because we needed it. All goals we had were implemented. We started cracking out 10 releases a year. Woohoo! We had 3 new categories, and operational quality improved, and most importantly, fun and engagement. We had the best IT year ever. So what made this a success? I think there was a sense of urgency. We really had to. We had the commitment of the board of directors. It sounds silly, but that really helps. Business and IT together. This was not some local thingy IT is going to reorganize. No, it was business and IT together. We did it both bottom up and top down, looking from both directions. And last of all, it was not a pilot. This was all in. All the chips were on the table. We had to make this work. And then, if you have simple rules and simple processes, people tend to be easier. And what did this for the virtual engineer, the person in the room? What did he feel for mastery, purpose, and autonomy? I think it improved on all facets. But we're still not there. This is 2009. And very interestingly enough, we were working then with 3 big monolithic systems, where you can be really agile, but if you're working with lots of developers on the same code base in the same deployable unit, it really gets very hard. We then decided we needed a service-oriented architecture. This is not our architecture, it's actually the one of Netflix, I think. But we wanted to move from the 3 large monolithic systems to many small, loosely coupled services. This was an evolution rather than a revolution. It's still ongoing. We'll still have those 3 big monolithic systems, but they're kind of smaller and less important in the company. And actually, hopefully this year we'll put the life out of one of those. We adopted the strategy of innovation and migration together. So innovate while you're migrating. That's really important in this case. And currently we are at 400 and plus services. And each team at bol.com, currently we have 70 Scrum teams, each owns a few of those services. So what was the promise? Independent development, yes. Independent deployment, come back to that a little bit later. Independent scaling, yes, you could independently scale applications. You had not had to scale the whole thing just to make the pricing module run faster. And increased ownership by the team. This was not this whole bucket of code you had to own. These were these small services which were really yours. And it also allowed to create fit-to-purpose solutions. So, long time ago, the only solution you had an Oracle database, you put some Java code on it, that was it. And now you could, each team could decide for themselves, do we want an Oracle database, do we want MongoDB, do we Cassandra? Anything they could wish for. It has really improved, again, the purpose, the mastery, and the autonomy of the teams. But we still had a problem. We were actually hosted by an external party. So every time we wanted to make a release, we had to go into contract negotiations, and every bug fix was a very hard thing. So let's run our own data center. Very bold move, I think, at that point. It meant that we had to bring in new skill set. We didn't have that many system engineers. So we had to bring them in and train them. What we actually chose was a strategy where we, at a certain point, froze all development on all applications for a short period and lift and shifted them all. Not trying to innovate, just lift and shift. We did this together with the external partner. He already knew how to run our systems. They could really help us with that. It took a long preparation time. I think that we were busy for more than 1.5 years setting up the data center, having all the stuff ready. But then we went live in one big bang night. People still talking about it at bol.com as being the best night they ever had. Was not there yet, so still hoping for it. This gave us more mastery and autonomy. We were still more in control of the things we wanted to do. But still, we're not there. And then we started our DevOps journey, what we called the man on the moon journey. Let's put a man on the moon. And it actually started somewhere in London, where one of the engineers said, I want one-click deployment. And this gesture actually still is quite famous at bol.com. With one deployment, one click of a button, I as a team want to be able to deploy code to production without any interference of an up the operations. For that means that DevOps in this case really works for autonomy for the team. Removing all handovers from the beginning to the end. It was really important. And not only deploying the stuff, but actually also running it on production. Famous acronym also in bol.com. You build it, you run it, and then you start loving it. This will really increase the quality of your code. If you as an engineer get the call if something is wrong with your code, you're not checking in any dodgy code anymore, I think. So what was the promise? Independent, push of a button, autonomous deployment to production. Applications run, at least during the daytime, by feature teams. They get the alerts when something is wrong. Increased ownership of those teams for that. Faster time to market. You can deploy any day you want, at any moment in time. And that really worked. Actually, currently, we're doing 60 to 80 deployments a day. Certain teams deploy every merge to master automatically to production. So what made this, again, a success? Again, a sense of urgency. We were kind of stuck in this thing. We couldn't make it fast. We inspire teams by maybe this is something you could do, but they decided themselves how to do it. Again, this was embraced by business. They wanted this shorter time to market, but it was driven by engineers. And what also really helped is give the teams time to adopt to it. Not every team is a front runner. Some teams need a little bit time to get adjusted. Some teams need more time to cut down on their dependencies. Give them their own team, and then let the front runner teams tell their stories, how great things are. It's not great to be a front on a team because you run into a lot of problems, but in the end you can tell the teams how it would really work. Celebrate success, but also celebrate failure. Results: number of user stories to production increased dramatically. Production deployments increased dramatically. Production emergencies decreased tremendously. And even then, when there was an emergency, the mean time to recovery was also decreased. At a certain point in my management team, people were asking the question, are the teams taking enough risks anymore? So that really, really helped us. And I think that instant feedback loop really improves quality and ownership of the teams. So now, where are we for purpose, mastery, and autonomy? Well, I think we score four stars on everything. So normally people 3 out of 5, it's great enough. But still, I think that we can do better. I think even that we need to do better. And this is where Maarten comes in, and he will tell the story of our Google platform journey.
Yes. Thank you, Leon. Right, so the Google Cloud. First, I'm going to tell you a bit about myself. I'm a cloud advocate, which means that internally I get people excited about going to the cloud, and externally I get people excited about how we're getting to the cloud. So the latter part of the job is why I'm here today. I spent the last 6 years at bol.com. I also started as a Java developer, just like Leon, and just like yeah, we were hired on the same day, in fact, and we have both since traded in our job of coding for a job of talking. And after the presentation, you can judge whether that was a good idea or not. And I actually started as a historian. I was trained as a historian, not as a developer. Because Leon had the quote from his field of study, I also have a quote. I have no idea who it's from. I think it was just one of my professors who came up with it. But I can't predict the future, but when something has happened, I can explain why it could not have been otherwise. So I have no idea what's going to happen, but as soon as it happens, I can tell you why it was inevitable. And that's pretty much what I'm going to do today with our cloud experience, or our cloud migration. We had no idea how it was going to go, but looking back, it was pretty much going to go like this, whatever we did. So, in 2017, bol.com was running its own ever-expanding data center, like Leon told you. Second, growing its developer support teams, crucially, to service ever more feature teams. So, we have, when I joined the company, there were as many people in the company as a whole as there are in IT at the moment. When we joined, there were, I forget, sorry? 400. Now there's 400 people in IT? And how many Scrum teams when we joined? When we joined, maybe 12. 12, and now it's like 70 or 75, something like that. So, but as we added more Scrum teams, we also found that we had to add more support capacity to get these teams and their applications up and running on our infrastructure. We were building our own container platform because, well, don't laugh, it seemed like a good idea at the time. We had this data center, we had all these VMs, we had all this infrastructure, but we couldn't run containers on them in any kind of sensible way. So we decided we were going to build our own container infrastructure or container platform on top of Mesos. And that project, the build your own container platform project, wasn't really going too well. And it was becoming clear that the IT platform that underpinned bol.com was becoming a bottleneck to our further growth. And so, while we were sort of hitting this wall in terms of the IT platform, some people went off to a conference called Google Next in San Francisco, and they came back with an idea, or rather with two facts about bol.com as a company, which are quite obvious if you think about it, but which hadn't yet really sunk in at that point. And the first one is this, that bol.com is actually a retail platform company and not an IT platform. Our core business is not building data centers and running infrastructure. Our core business is providing a platform that people can use to sell stuff on. That's what we do. We have sellers, we have partners, and we sell stuff ourselves as well. That platform, that is the core of our business. Building a data center, hooking up all the wires, making sure the machines are patched, etc., that is not our core business. But it was taking up a lot of our time because we were doing it ourselves. And the second is, no matter how hard we try, bol.com cannot ever out-innovate public cloud provider platforms. Why? Because Google and Amazon and Microsoft and whichever other public cloud you care to mention has a multiple of our total company size working on just that platform. So we do not have the financial capacity, we do not have the engineering capacity, we do not have the organizational capacity, and nor do we have an interest in trying to compete with public cloud providers on the services they offer to try and offer those internally. And that is true even if we focus just on the things that we need. So we don't need to replicate the entire Google Cloud platform or Microsoft Azure platform. We just need a couple of things. But even those things, if we just concentrate on those, there's no way we're going to be able to make it as good or as feature-rich as they can make it, simply because of lack of time, money, and an interest in doing so. So, and the other part, as I said in the slide with describing the wall that we were hitting, it was pretty clear that in order to be able to grow to more feature teams in the future, and to have that mean that we didn't grow the support teams along with them, because that's not a scalable situation, we needed to give the teams even more autonomy that they already had. So Leon talked about this whole journey to where we had the Man on the Moon project, where teams could deploy their own software. We needed to move beyond that, where teams could deploy their own infrastructure and could basically do everything they needed to do without ever talking to anybody else outside the team, because everything would be self-service. If not, we were looking at a situation where we were scaling the support staff along with the feature teams, and that is not what we wanted. So, this group of engineers came back from Google Next, and surprise, surprise, they thought it was a good idea to go to the Google Cloud. Can't imagine why. This is what I talked about before. So on the, for the kijkers links, on your left, you have the chart where they plot the chart that shows the amount of resources we would need in terms of platform operations if we were to keep running on our own data center. So as you can see, the green line rises along with the tools being managed and along with the innovation capability. So if we want to keep innovating, we need to add more and more and more engineers to the platform because we're building it ourselves. On the right is the situation where we move to the cloud, where that basically, the green line flattens out. So we can support more innovation, we can support more feature teams with the same core platform team doing the work because of all the autonomy stuff and all the stuff that Google does for us. So the question that I get asked the most when I talk about this is why you should go to the cloud is pretty obvious to most people, but then why did you go to the Google Cloud platform? And the answer is, well, there's three big cloud platform providers, as you all know. There's Amazon, who is essentially a direct competitor of ours, so management didn't really think that was a good idea to host all our stuff there. I mean, not that they would like turn off our VMs just to screw with us, but still. Then there's Microsoft Azure, which our parent company, Ahold, actually already had a contract with, so that was a serious option. And then there's Google. But the people who actually made the decision as to where we should go are the people in this picture, and they're not literally the people in this picture, but they're like representatives of the development and engineering community that we have at bol.com. They said, well, we have some experience with the Google Cloud platform. We really liked its developer friendliness. We liked the Google stance in terms of open source. This was before Microsoft bought GitHub, et cetera, et cetera. We really like all the stuff that Google is doing and the way that it has certain emphases. So let's go with Google. And that's what we did. So it's a really nice instance of management actually listening to the engineers and making its decisions based on what the engineers want. Of course, it wasn't just a gut feeling. There was also some technical reasons. So we knew from the start that we wanted to run everything on Kubernetes in the cloud. And obviously, Kubernetes was invented at Google. So at the time, they had by far the best Kubernetes tooling, and arguably they still do. There's TensorFlow. TensorFlow is a machine learning technique or a machine learning library, but it's sort of a symbol for the entire machine learning strategy at Google, which is basically that they do everything machine learning first. I'm not sure exactly what that means, but they have a ton of great tools that allow you to do machine learning. They have specialized hardware that helps with machine learning, and they have machine learning hooked into almost every cloud product that they provide in a really nice way. For example, BigQuery. BigQuery is the platform that is meant for insights that now hosts basically, well, not yet, but hopefully by the end of the year, hosts all our business insights. That also has all kinds of links to the machine learning infrastructure. You can actually take your data and learn from it in a really easy way. So those were the three things that really kind of sold us on Google, apart from the fact that the developers liked it. One of the nice things about moving to a cloud platform is that if you think you want to build some sort of tool, chances are pretty good that Google's probably already built it. So Google has an extremely large and ever-expanding portfolio of API-driven products that it manages and provides to its customers. And in fact, the portfolio is so large that it's basically like a day job to try and keep up with all the updates that are and the product announcements that are appearing more or less daily. Reinventing whatever wheel you'd like to reinvent on top of that cloud platform when there's already product available is almost never a cost-effective idea. So what we essentially have is the entire Google platform, all the Google platform product teams and engineers who are essentially now working for bol.com, providing us with features and products that we can use. Also, there are certain features of the Google Cloud Platform that we have already replicated in-house because we built them before we knew that we were going to the cloud. Also a good idea to get rid of those, because it's just extra operational burden that you have that you can replace by something that is managed for you by a third party, which is always the better option. And experimentation becomes really, really easy. You can try all sorts of stuff without having to procure hardware, without having to worry about how you're going to impact production workloads, etc., etc. Basically, it makes it really easy to focus on what makes bol.com special as opposed to running the underlying platform. So, Leon had a picture of Darwin. I have a picture of a perhaps somewhat less famous scientist. Does anybody here know who this guy is? Really? Yeah, so. Werner Vogel, thank you. Werner Vogel, who is an actual scientist. He has a doctor's degree, or a PhD in computer science from Cornell University. So, but probably less famous than Darwin, let's be honest. Werner Vogels, he is the CTO of Amazon.com, also known as the boss of AWS. Amazon Web Services, sort of the pioneers of cloud computing, and also a purveyor of interesting insights into how you should think about the cloud and how the cloud will change the culture of your company. And so, what you should do, according to Werner, and I think he's totally correct, is to stop thinking in terms of traditional limitations. You no longer need to worry about, if I'm going to launch this feature, how many users will I have? And how much hardware does that mean I need? Something you don't need to worry about. You can actually just launch features and measure the actual usage, and whatever you need from your cloud platform can be provisioned very simply and in no time. So there's no need to worry in advance about how much use your application will see, how much load it will have, etc., etc. Don't try to predict usage. Stop trying to predict usage. And at the outset, think and design as though you have unlimited resources. Because, so for a company of the scale of bol.com versus a company of the scale of Google, for all intents and purposes, Google has unlimited resources as far as we're concerned. Whatever we think up, Google can probably handle. And if we're going to hit anything, it's rate limiting and not actual resource constraints at Google. So design and engineer as though you can scale infinitely and just deploy stuff and see if it works. But you have to mind the costs, because one of the things that the cloud gives you is really concise cost insights. And now you can actually do stuff like, hey, I'm going to develop this feature. It's going to run on a VM. It's going to run on a container. It's going to run on BigQuery. I know exactly how much that feature costs. And then I can go see, how much revenue does that feature actually produce? Is that revenue the same as the cost? Is it more than the cost? Is it less than the cost? And I probably shouldn't be running that feature. That's stuff that you cannot do, or let me rephrase that. Stuff that we cannot do in our data center because nobody knows what anything costs. I'll get back to that in a second. And so one of the problems of the cloud platform is the fact that it has so many options, right? That's at the same time the great thing, and at one point at the same time the great and the sort of huge pitfall of cloud platforms. You have so much freedom to do whatever you want. You have to work really hard not to shoot yourself in the foot. The Google Cloud Platform has a ton of different possibilities, and we had to create a framework to make sure that people were doing the right thing and in the easiest way and not having to reinvent the wheel all the time. So my favorite example of this is if you provision a VM in the Google Cloud, it gets a public IP address by default. And one of our security engineers did this and left that VM running for 20 minutes and then made a plot of all the locations on Earth that tried to break into the SSH server on that VM. And within like 10 minutes, people from the Seychelles were trying to break into that VM just because it had a public IP. I gotta say, it must be pretty great to be a hacker on the Seychelles, but so that sort of thing, you want to turn that off, and you want to make sure that nobody does that by accident. So we had to adapt to the cloud, and adapting to the cloud means creating a cloud platform on top of Google that enforces security measures. This is really important. Don't provision public IPs by default. Make sure that all your buckets that contain sensitive data can't accidentally be accessed in a public manner. We may or may not have had that happen. So make sure all that stuff is baked into the platform that you build on top of Google and that developers can use, so they don't need to think about that stuff. Encode best practices. If you know how to scale applications, if you know a certain way that you as a company want to handle certain types of configuration, certain types of deployments, et cetera, build all that stuff into the platform so developers don't need to actually think about it. Make sure they can just deploy and be done with it. Ease the cognitive load for developers. Make sure that they can focus on that business logic and they don't need to worry about, is my traffic from one server to the other encrypted, and should I be encrypting, et cetera, et cetera. Just make sure that stuff just works for them. And finally, make it really easy to customize whatever you've built, because there will always be people who want special stuff, who want just a little tweak in the configuration. That needs to be possible without everybody getting really frustrated. By default, Google, and this goes for every cloud platform, is not adapted to the way that you work as a company, and you will need some sort of tooling at a certain scale. I mean, if you're a group of 3 people, then you should be fine, but at a certain scale, you will need tooling that creates a paved road for your engineers. So, how do we use the cloud? Well, we have this framework which creates this paved road, which means that by default, if you have simple requirements, everything is really, really easy. Deploying stuff is incredibly simple. You don't need to worry about anything except writing your code. That's what we call the paved road. And not a term we invented, but we like to use it. The paved road, really easy going. On the other hand, you have this mechanism whereby you can actually tweak all the knobs as well under the hood if you want to, but you don't need to. You can, but you don't have to. So that's how we've created this framework and we've rolled it out internally, and that's how we use the cloud. So, what has all this brought us? Let me just, What has all this brought us? Well, improved developer productivity. That was like, in terms of developer community inside Bol.com, that was like goal number 1, right? And that has been delivered. We have now, on average, a new service to production taking 3 days, depending on exactly if you want your service to not do anything, it'll take like an hour. If you want to actually have some code that does actual work, it'll take about 3 days. Instead of 2 weeks. That's a huge time gain. And we've self-serviced. We've made everything, almost everything, completely self-service. So provisioning infrastructure, making sure that your app has monitoring, et cetera, all that stuff can be done by the Scrum team itself, so that the Scrum team or the feature team can go as fast as it can and not be dependent on anybody else. We've had huge technical improvements in our stack, obviously because Google allows us to leverage platforms that we could never build ourselves, like BigQuery, even the Kubernetes platform, GKE. Of course, you can run Kubernetes on-prem, but it would never be as good as GKE, or at least not unless you spend a ton of money on it. We have vastly superior cost insights per team. So this is, like I said before, in our data center, nobody knows what anything costs because you have the capital expenditure, you buy your servers, but then it costs something to run them as well because you have the electricity and network connectivity, et cetera, and then this sum becomes really, really difficult, and in the end, there was like one person in the company who everybody thought understood how much it costs to run a service in a data center, and it turned out he didn't really get it either. So at Google, you just get like a bill for what you use, right? If you want to run a container, it's now to the point where in GKE, Google can tell you, well, running this container costs you X amount of money per hour. running this query on BigQuery costs you X amount of euros, you can actually pinpoint down to the cent how much what you are doing costs on the platform. And that's great because of the example I gave earlier. You can actually start to figure out the business case for a feature or for a service that you want to launch. And finally, we have huge security improvements. So the first thing that our security team said when we said we wanted to go to the cloud was to kind of turn gray and start hyperventilating. But then they were suitably indoctrinated by the Google people who actually convinced them, well, in terms of a whole bunch of things, moving to the cloud really increases your security. Because, for example, Google has a hardware encryption chip in every one of their physical machines that makes sure that the boot process is safe, et cetera, et cetera. That's to security to a degree that you can never achieve on your own unless you were a security-specific company or unless you invested a huge amount of money. All the data that you store with them is encrypted at rest, et cetera, et cetera. So there's all these things in which immediately your setup becomes a whole lot more secure because you move to the cloud. Obviously, there's still some there are still some things that are somewhat more of a challenge. For example, even though that data in that storage bucket may be encrypted at rest and replicated, et cetera, if you set it up in such a way that you just need a key to access it, and the key leaks, that's the attacker accessing your data right there. Whereas in the data center, you have firewalls, et cetera, et cetera. So there are unique challenges to the cloud that you need to figure out. But on the whole, things become a lot more secure. So what did this do for the metrics that Leon talked about? So it maxed out autonomy, right? Everybody is now as autonomous as it's going to get. Unless we give them a credit card and their own Google Cloud account, it's not going to get very much better. And that would be a really bad idea, just in case you're wondering. So, finally, don't become the next dodo. This is the first time we're talking about dodos in this presentation, right?
Yes, first time.
Yeah. So, don't become the next dodo. I'm going to combine Leon's discipline and my own and tell you the dodo is a flightless bird that went extinct on the island of Mauritius. And there are people that will tell you that it was killed off by the Dutch, but I'm here to tell you that no, it was actually the Portuguese that killed it, so keep that in mind. You don't want to become the dodo. The dodo went extinct because it didn't have the qualities it needed to survive. You need to find your own bottlenecks. You need to find what's going to stop you from growing further, adapting further, making the changes that you need to make. You need to experiment, measure, learn, and adapt. This is like there's some sort of acronym for that loop, I think, but you need to allow for failure. This is what evolution does, right? There's a whole bunch of failures, which in terms of evolution means a whole bunch of death, but fortunately in IT it's not that stark. You can just like launch software and have a bug and then fix it. But you need to allow for that. We did that. We had the same thing in our cloud journey where we had a whole bunch of things that we tried out, didn't work. We had to go back and sort of rethink things, and then finally we came up with the winning adaptation, so to speak. You need to work bottom up and top down. So it's really important that the engineers are on board, but it's equally as important that the management is totally behind the whole cloud vision and really believes in what you're doing. Because if not, then you kind of lack leadership, and then people start sort of doing their own thing, and it becomes chaotic. And finally, you need to allow for local variations, which means that you need to have this paved road, but you need to not force people onto the paved road. If they want to do something different, you need to let them. You need to, because being former engineers, Leon and I can tell you that the worst thing to tell an engineer is that he has to do something, because whatever it is, even though it's like the best idea in the world, immediately he'll say, forget it, I'm not doing that. And then you have to make him do it, and that's like that's a bad idea in terms of the motivation of the engineer. So change needs time and attention. I guess that's pretty obvious. Change can happen overnight, as we experienced with the introduction of Scrum, but it's usually when your company kind of depends on it, and that's not really a good place to be. So if you're in a somewhat more relaxed place, then change will take time and attention, and that's great. I mean, that's what you want, right? You You want to actually think these things through and not be rushed. So that's the end of the presentation. If you're going to take away anything from what we've said today is, or let me rephrase that. I think your main takeaway from what we said today is to not become a flightless bird threatened by Portuguese. And apart from that, yeah, you need to keep changing. Obviously, you need to keep adapting, but that's actually a lot of fun. I mean, it's not. It sounds like a lot of work, and it is, but it's what keeps things interesting, and it's what keeps developers motivated. It's what keeps people interested in the project, in the mission. This constant adaptation is actually a good thing. So, thanks a lot.
Thank you very much, Leon, Maarten. Do you have time for some questions?
Yeah.
Yes.
Yeah? Okay.
Do you have time for some questions?
Yeah.
Okay.
The whole evening. Okay. First question. For ball.com. Yeah.
Just a disclaimer, I've now told you pretty much all I know about the dodos, or any more questions along those lines can be directed to Leon.
I'm out of it. I thought the Dutch killed it. Getting 5 stars on it. I think we can improve on purpose by aligning business and IT even more. I think today we had some excellent stories about end-to-end teams being really responsible also for the output. I still think that we can learn a little bit there, I think. Mastery, I think you can never be master. You still need to learn. And I think that's also what Rini said. If you have a company where learning is in the essence, where experimenting is in the essence, then mastery will become more even better. But that's developing that learning culture, I think, which is essential.
Staying at a 4-star, I think that's the most important part of it. Staying there.
Yeah.
Instead of 5 stars. Yeah.
Yeah, so I'm going to remind you that my job title is Cloud Advocate, so you can maybe infer from that why I didn't talk. No, I'm just kidding. So actually, in terms of the technical challenges, so you have the security challenges for sure, and the security challenges are not the fact that it's not secure, but that you need to really think about how you solve the security issues in a different way than you do on-prem. And for the rest, there's a whole bunch of technical challenges around adopting a new platform, but that goes for any platform, I guess. The biggest change in terms of on-prem is that everything becomes an API, and things become really easy to do. And so when things become really easy to do, things also become pretty easy to get wrong. So we had this Hadoop job that that a team migrated from on-prem Hadoop to the Google Cloud, and they configured it in more or less the same way that they would in the data center, and it used like 200 VMs for 10 hours and cost 2,000 euros per run. And so then they did this a couple of times until people found out that they were actually spending a lot of money. And then they went back and they actually refactored the whole thing to use BigQuery, and it took 45 minutes and cost 5 cents per run. So the challenge there is to actually use cloud native technologies in the way that they're meant to be used, and not just do what you did before, but in the cloud. And the other challenge is to keep your costs under control. And Google has all sorts of ways to actually give you insights as to how much you spend. But at a basic level, if you use resources, they're going to charge you for it. And if you use resources in a stupid way, they're going to charge you for it anyway. And you can't say like, oh, sorry, I didn't mean to do that. Please give me my 2,000 euros back. So you have to actually watch that pretty closely, and you have to make sure that it's okay to make mistakes, right? adopting new technology can cost money, but you have to make sure that you don't make the same mistakes twice. So whenever this happens, make sure you put in necessary controls that alert you to this stuff beforehand, or make sure that you improve your framework to such a degree that that these things don't happen anymore. And a good example of that is, so in the DC we have all these physical machines that run all the time. In the cloud we have all these VMs, but we also have a test environment, and there's really no reason to keep the test environment around at night because nobody's using it. So what we do is for every application that we launch, by default we turn it off at like 7 in the evening, and we turn it back on at 8 in the morning on the test environment because nobody's using it in between those times, but it is costing money. So you can do all sorts of clever things that you can't do in the data center, but you need to actually figure that out, and it'll probably involve a little bit of pain and some amount of money lost.
Yeah, and as a biologist, I'm a really big fan of feedback loops. That's how biology works, with feedback loops, and I think the financial feedback loop towards a team, the quality, and actual towards the business behind it is one of the greatest things you will ever find.
Very much. Is there another question? I'm sorry. Yeah, works again, I think.
It's just for show.
Hopefully.
Yeah, it does.
Yeah.
What's your ambition on closing down your own data center? Your ambition on timelines?
That's another hard part, I think. Again, this is a migration. I don't think that we're ever going to be 100% in the cloud. There are certain applications, some of the old monolithic systems which run on an Oracle database, which are kind of hard to migrate, which have a lot of logic in the database. So probably they will stay on it. I think hopefully that will be migrated to 60 or 70% in 2 years.
And,
But
yeah,
allowing for the pace.
we are more on the same journey, and I'd like to discuss maybe offline why it takes 3 days to deploy an application, because I work in a financial institution, a dinosaur in your eyes, and we can deploy in minutes to production.
Oh, we can deploy the production.
Yeah, but if you have zero, an empty account, then still we can deploy from zero to complete working stack in a couple of minutes. Only thing that takes long are huge applications for, I don't know, 30 terabytes. That takes maybe 3 hours.
Yeah.
So I'd like to discuss why maybe we do something wrong, or we
sure.
can.
Yeah.
Cool.
That's
Yeah.
consulting.
In terms of actually turning off, so like Leon said, we have the data centers that run in our warehouse that will never disappear because they're like a local cache for orders, and if the internet
That's a physical warehouse, not a data warehouse.
If the internet connection goes down, we still want the order pickers to be able to work, so that will never disappear. And in terms of the sort of general data center, we have there's a bunch of stuff running there that we cannot move to the cloud for because of licensing purposes, to be honest. And so this is a great point that we should tell something more about the dodo. So the dodo, bear with me. So the people ate the dodo. That's why it died, right? The dodos became extinct because people ate them, but they actually tasted really terrible. They didn't taste good at all, but people ate them anyways because they were hungry and, sailors and this sort of thing. And so the dodo is a lot like an Oracle database, right? Nobody wants it, and it's going to die at some time in the future, this you know for sure. But while it's still around, you have to deal with it, and this is one of the reasons why we can't, say we're going to get rid of our database, we're going to get rid of our data center tomorrow, for instance, because we still have these impediments, these dodos running around, refusing to die, essentially.
We should get the Portuguese in then.
Yeah, we've been hiring Portuguese like crazy.
Yeah.
They'll take care of it.
Okay. Last question. No questions? Okay. Big applause for Maarten and Leon.